A simple example of a function is a linear function. It's also called a polynomial of degree 1. So a linear function is a function written in the following form. So it's a constant times the variable x plus another constant. So this is a linear function. And this number here, we will come to that, is called a slope of the linear function. For example, the price of a taxi cab ride, that's a linear function as we presented it. So it was fixed price of 5 plus a kilometer price of $2 per kilometer. Or here we could just as well write them in opposite order. So here we have k, and here we have m, but it should be not m there, it should be 5. So this is m. So this is an example of a linear function. There are many other examples of linear functions. For example, the distance an object travels, if it moves at constant speed, we have seen that it's this function here. That is also an example of a linear function. For example, if v is equal to 10, then this is 10 times t. And we can of course add here 0. So then we see here that this is k and this is m. So linear functions are important and also elementary. Like I said, we call this the slope of the function. So why do you do that? So let us draw a linear function in a curve diagram. So now we want to draw the following curve, or the graph of the following function. And this is now a linear function. So how does it look if we put it into a coordinate system, a curve diagram? So we should have x here, y here. Okay, so let's make a quick table so we can draw the graph of the function. And we just choose some numbers. 0, 1, 2, 3. So if I plug in 0, we get 3 times 0 plus 2, that's 2. 3 times 1 plus 2, that's 5. 3 times 2 plus 2, that's 8. And 11. So now if I plug this into my coordinate system, okay, so 0, 2, then I'm here. And then 1, 5, 2, 8, and 3, 11. So if I connect this with a line, straight line, if I have done this more carefully, you will see that all of these lie on a straight line. So if you take all x's here and all corresponding y's, you see that all of these points will make up a straight line. So a linear function will always have a straight line as a graph. And then you see that, okay, it has some kind of slope here. And since we call that the slope, that must be connected to that number some way. Otherwise, it's a strange selection or choice of the name for this. So why is this called a slope? Okay, so we want to have a measure of the slope of this curve. How could we have that? Yeah, one way of doing it is, for example, if we go one step in this direction, how many steps do we have to go in the y direction? Okay, so if we go one step here, how many steps in the y direction? We see here that if we go from 1 to 2, we have to go up 3. And the same for every step we take. We go from 0 to 1, we go up 3. From 1 to 2, we go up 3. From 2 to 3, we go up 3. So this number 3 appears when we go one step, we go 3 up. And of course, this number here, how much you go up or down when you go one step, that's a good measure of how what is the slope of this graph. So this number here, 3, is how much you go up or down when you go one step in the x direction. And therefore it's called a slope, since it has to do with the slope of the curve. So if you have a function, linear function, kx plus m. So if you have a function with a positive k, then the curve goes up. And if you have a curve that goes down, or a straight line that goes down, that means that k is negative. So here, k is negative. For this one, k is positive. And if it's equal to 0, then we have a horizontal line. So if you have a horizontal line, then k equals 0. And the larger this number is, the greater the slope of the curve, or the more negative it is, the greater the slope downwards. So this number here, k, has to do with the slope. Okay, so what does this number m has to do with? It has to do with where on the y-axis it crosses the y-axis. So for this curve here, what the coordinates of these points? Okay, the x-coordinate is 0. What is the y-coordinate? If I plug in 0 here at x, this becomes 0, and this will become m. So y will become m if x is 0. So this point here has coordinate 0, m. That is, this here has the value m, y value m. So m is the value where it crosses the y-axis. And this is the slope. So a straight line is dependent here. The linear function is dependent on two numbers, where it crosses the y-axis and what slope it has. If we know these two numbers, we know all we know about the linear function. So if you have the graph of a linear function, how can we calculate k, the slope? So how can we calculate the slope? We can do it by taking 2 points on the graph. So let's take 2 points here, 2 arbitrary points. So let's call this x1, y1, the coordinates of that one, and this x2, y2. So x1, you have x1 here, y1 here, and so on. Okay, so now we want to calculate the slope. That is, if we go one step in this direction, how much should we go in the y direction? If we look at this, the distance here, how long is this distance? It is the x-coordinate of this one minus the x-coordinate of that one. So this distance here is x2 minus x1. And how high up do we go? So what's this distance? That's y2 minus y1. We take the difference of the two y coordinates. Okay, so let's say, for example, that this here is equal to 3, and this is equal to 2. So if we go 3 steps here, then we go 2 steps up. Let's assume that. How much do we go up for every step we go here? Okay, so we go 3 steps here, we go 2 up. That means that if I take 2 and divide by the number of steps, so this is how much I will go up if I go 1 step on the x-axis. So if I go 1 step here, I go 2/3 up to follow the line. Or more generally, now it was only example 3 and 2. More generally, the 2 is this. So we should have 2 minus y1, and this should not be 3 but this. So in general, the slope here will be that. So the slope of curve is, if we go 1 step here, how much do we go up? We go up this much. So the slope of the curve is given by this formula. So this is a 2-point formula because we're using 2 points on the line to calculate the slope. So if we know 2 points on the line, we can calculate the slope from this formula here. Let us, for example, say that we have these points are, let's say this point is 2, 3, and this point is 5, 11. What will be the slope in this case? Yeah, then y2 is 11, y1 is 3, x2 is 5, and x1 is 2. So this will be 8 divided by 3. So 8/3, or that's roughly 2.7. But exactly 8/3. So this is how we can calculate the slope if we're given 2 points on the line. So that means that for every step we go in the x direction, we have to go 8/3 up. And then if it would have been a negative number, it means that for every step we go in the x direction, we have to go down that much. If I have a curve looking like a vertical line, what will be the slope of this line? So what will be the slope of this line? Yeah, if I take 2 points here, x1, y1, x2, y2, and try to calculate the slope, then we see that this here, this is equal to 0 because the x coordinates are the same. They correspond to the same x. So here we have to divide by 0. And it's not possible to divide by 0. So the slope of this one is not defined. And if it would have been anything, we'd probably say that it's infinity. Because if you take something with a high degree of slope, it decreases larger and larger. So when you have a larger and larger slope, we come closer and closer to this line here. So we go to infinity. But this vertical line here, that is not in the graph anyway, so it doesn't really matter, because this is not the graph of a function. And why is that? For example, if I try to read off the function for this point here, then where should I go up? There are infinitely many points I have to go to the left for. So this does not define a curve, because there's not a unique y for every x. Okay, so in this case, it's not the function. But still, we would like to have a way of writing this curve here. So let's say that this point over here is 3. So let's say it crosses at the x-axis at 3. Then we can write this line as x equals to 3. So if you have a vertical straight line, then we write the equation for that, or the formula for that, or we would like to call it as x equals to 3, because x is equal to 3 no matter where we are on this. So this is an exception. This is not a function, but this is describing a vertical straight line. If I instead, of course, if I have a horizontal straight line, then it is a function, because for every x I have a unique y. And this you would have written then y equal to not 0, but if it had crossed here, for example, at 2, then this would be y equal to 2, because it's equal to 2 for all x. So in this case, the slope would have been 0, because y2 minus 1 in this case would have been 0. It's easy to sketch a linear function, the graph of a linear function. For example, let's say that I want to sketch or draw the linear function, the graph of the linear function 2x plus 1. Then that's easy, because if I have 2 points on the straight line, I know the straight line. So if I have 2 points, I can just draw a straight line between those. I have the straight line. You see, in this number here, as we have said, that corresponds to where it crosses the y-axis. And 2 means the slope. It means if I go 1 step here, then I should go 2 up. And now I have 2 points. So now it's just to draw a straight line going through these 2. Like that. So if I take a ruler, I can draw a straight line. Or for example, if I have instead minus x plus 3. What is k in this case? Yeah, he's minus x, but of course we can write it like this. So in this case, k is equal to minus 1. And here we have 3, meaning that it will cross here at 3. And then if we go 1 step in this direction, we should go down 1, because k is equal to minus 1. So we have the next point here. And now we can connect. So this is the graph for this function. So it's easy to draw a graph of a linear function. You only need 2 points on the line. If you know, for example, here where it crosses the y-axis, and you know the slope, you can draw it easily. So let's take an example where we know k, the slope. For example, we know that is 4. But let's say that we don't know where it crosses the y-axis. We don't know m. But instead we have another point on the line, 3, 2. So we know that the curve or the graph, the straight line, goes through this point and has this slope. Can we figure out which linear function it is then? So which one is it then? Yeah, of course, we know k, so we can put that directly. So we know that it must be this form. So what only thing we're missing is m. So how can we figure that out? Yeah, we know that this point should lie on the graph of this function. That means that if I plug in 3 here as x, then y should be equal to 2. So if this lies on the graph of this straight line, meaning that if I plug in 3, I should get out 2. So this must hold, since that point lies on the line. And here we have an equation in terms of m. So we can solve what m is. So if we remove this from both sides, m will be given by this. This is 2 minus 12, so minus 10. And now we know the function. Now we know that k is 4 and m is equal to minus 10. So we don't have to know where it crosses the y-axis. We only have to know a point on the line. So if we know the slope and any point on the line, we can figure out what the function is. You can also use what's called a one-point formula. And the one-point formula we can write like this. So if we know k and we know one point on the line x1, y1, then we can figure out the function using this formula. For example, in the case we just had, then this was 4 and this was 3, 2. So in this case, the one-point formula would give us that we have y minus y1, and that's 2. K is 4 times x minus x1, and that's 3. And here we can just simplify. Multiply in, then we get 4x minus 12. And if we move up over 2 to the other side, we get 4x minus 12 plus 2, that's minus 10. And that's the same thing we had just for a moment ago. So you can also use this one-point formula. We leave it as an exercise for you to show that this formula holds. It's not so difficult to prove. Instead of knowing k and 1 point, you can just as well know 2 points on the line. It's well known that if you have 2 points on the line, on a straight line that is, that determines the straight line completely. Because if you have 2 points on the straight line, you can just put that 2 points out and draw a straight line with a ruler between them. Then you have the straight line. So how can you do that in practice? Yeah, if you want to find out the straight line, you need to know what is k and what is m. So let's start with k. We know that it goes through these 2 points. So what is k given by then? Yes, as we have seen before, that k is given by this formula. So if we have 2 points, we can calculate k using this formula, or definition if you like. Okay, so let's say we have 2 points here now. We have 1, 3, and 5 minus 2. So what will be k then? Okay, y2 is minus 2. y1 is 3. x2 is 5. x1 is 1. So this is minus 5 divided by 4. So this is minus 5 fourths. Or minus 1.25 if you like. Okay, so this is, then we have k. So now we know that the line must be minus 5 fourths x plus m. But then we only have to figure out m, and then we are back at the situation we had a while ago. We know 1 point here, or we know 2 points. So that we can take any of these 2 and use that to find out m. So let's just take the first one for simplicity. If I plug in 1 here into my function, so we know that this straight line goes through this point, meaning that if I plug in 1, then y must become 3, since this lies on the line. And here I have an equation for solving m. So I can just solve m here. It's 3 plus 5 fourths. And 3, that is 12 fourths plus 5 fourths. This is 17 fourths. So now I have m. So I can just exchange it here. and here is now my straight line. So if I have 2 points on the line, I can easily figure out the straight line. Then there is also a 2-point formula, similar to this, one can use in this case. Here I have 2 points. There is also 2-point formula, so let's look at that. So if you have the 2-point formula for linear functions, then the formula is this. And where does this formula come from? This is exactly the same formula in the 1-point formula, but where we have changed k for this, since this is the definition of k, or how you calculate k if you have 2 points on the line. And for example now, if I have 2 points on the line, I can use this one. So let's say I have these points. What will be the result from the 2-point formula? This x and y are of course a generic point on the line. y1 is this 2, y2 is 5, y1 is 2, x2 is 3, and x1 is 1, and x1 was 1. Now I only have to simplify this. 5 minus 2 is 3 divided by 2. And if I multiply in here, and then move over this 2 to the other side, minus 3 halves plus 2, that's plus 1 half. So then I get the straight line like this. So this is the 2-point formula. And as a final thing, let's look at proportionality. That is a special case of a linear function. For if two things are proportional, if y and x are proportional, that means that are related by a constant. So if I always can find y given x just by multiplying by some fixed constant, then they're proportional. So this holds. That means, for example, if I double x, then y doubles, and if I three double x, y three doubles. So that's proportionality. But this is just a special case of linearity, the linear function, because I could add a 0 here. And then we see here, this just corresponds to m be equal to 0. So if I have m equal to 0, I have proportionality. So a linear function I can write like this. And if this is 0, I have proportionality. So proportionality, it means that if I double this, y doubles, and three double this three doubles. But the same thing does not hold for linearity. For if I double this one, y does not necessarily double. It only happens if this is 0. If this is not 0, if I double x, this will not double. So linearity is more general than proportionality. This is just a special case of linearity. So for example, if we had our taxi cab ride, we had that you paid $2 per kilometer plus $5 fixed price. If I go twice as far, I don't pay twice as much here. For that to happen, then there would have to be no fixed price. So if there would be no fixed price, well, let's change this to some other kilometer. Let's say it's like this. You pay no fixed price, but you pay a higher kilometer price. In this case, if I double the distance I go, I double the price, because this is proportional. It's an example of this. But this is not an example of proportionality, it's linearity.